So this is the first chapter of part 8, chemical reactions and energy. So in the following three chapters, we're going to talk about how we're going to measure the energy gained and released during the chemical reactions and what kind of chemical reactions we can have. But before that, we're going to talk about the conservation of energy, and also you have to know what is system and surrounding first. So chemical change in chemical reactions. So every chemical reactions, there will be an energy change. For example, in this one, you see that we put sodium chloride into silver nitrate solutions. And in the process, we are forming some precipitate, AgCl. The reaction should be Ag plus Cl minus become AgCl solid. So we have an AgCl solid formations, and in the process you can see the direction of the arrow. The heat is giving out. So during a reaction, actually there is energy transfer between the system and surrounding. In this case, the system will be the chemical inside here. That means it will be the sodium chloride, silver nitrate. These two are the system. And the surrounding, we're talking about maybe the water, to dissolve the silver nitrate. So we got some surroundings here. And also the test tube is the surroundings. The atmosphere, the air around the test tube, that will be the surrounding. So in this case, when these two chemicals react, when they form this precipitate, energy, heat as a form of heat, they will give out in all direction. So the system is releasing energy to the surrounding. So the study of this energy change, in this case, is releasing energy. When we study this kind of energy change during chemical or physical changes, we call this study energetics. So, law of conservation of energy. I think you should understand we cannot create or destroy. Cannot create nor destroy energy. Energy can only transform from one form to another. So, you have to know that. That total amount of energy always remains constant. So in case 1, formation of silver chloride precipitate. So in this case, we will find that in the system we have the silver nitrate, sodium chloride. And then just now we mentioned if the silver chloride they combine, an AgCl ionic bond is formed. So during this bond formation, some energy is released. So where is the energy go? The energy will change from the system, go to the surrounding. So in this case, you'll find that surrounding, the energy level will increase with more energy in surrounding. But in the system, the energy will decrease. These changes, one decrease, one increase, they will be equals. So we'll say that law of conservation of energy. While in case 2, when we dissolve sodium chloride solid, when we have solid here, we put it into the water. Then we will find that the sodium chloride solid will break down into 2 ions, sodium ion and chloride ion. So in this case, energy is taken up from the surroundings. Where is energy coming from? It is coming from the surrounding to break the sodium chloride ionic bond. So in this case, the energy in the surrounding, we'll find that the energy will decrease in the surrounding. After energy absorbed here, the energy in the system will then increase. So the energy in the surrounding decrease or equals to the energy in the system increase. Then we'll say that is law of conservation of energy. So next, so you can have a look right here. When you hold a flask, so the flask, let's say, we consider the flask as a system. So this one is the system. The flask is the system. So your hand, it should be the surrounding. If, on the pictures on the left-hand side, you feel warm, you feel some heat coming out from the system. So you expect that, actually, the system is giving out some heat energy. So they will have, So they will have heat coming out. So we'll call this kind of reaction exothermic. exo means that it's going out. Exo means outside, just like the word exoskeleton, endoskeleton, things like that, okay? So exothermic, okay, means that heat is released, okay? Heat is released. But on the other hand, release. Okay, but on the other hand, if you feel cold in the process, okay, that means some of your energy, okay, they will be absorbed from your hand into the system, okay, so as the surroundings, okay. So in this case, we say that the reaction is endothermic, okay. Endo means inside. That means in the process, okay, heat is absorbed. Okay, so basically when you hold a beaker, you find that it's getting warmer and warmer. That means the reaction occurring is exothermic. While on the other way round, if you hold something, you feel very cold. Actually, it's absorbing your energy. We experience this kind of phenomenon. Okay, when you hold ice, when you hold the ice, you feel very cold because during the process, the ice absorbing the energy from your hand. Okay, to overcome the attractions between the water molecules. Okay, so in a solid, okay, you will find that the ice is very close, right? So in a solid state, okay, it will be like that. So after you absorb energy, then you can break the energy, then they will be further apart. So at that time, it will then melt. Okay, so when you feel something cold, that one will be endothermic, while the other side, okay, when you feel something warm or hot, the reaction is exothermic. So let's have a look. If now you are the thermometer, on the left hand side, we find that the reading of the thermometer, it goes up. Okay, the reading of the thermometer, it goes up. Okay, that means that, okay, the liquid inside the thermometer, okay, remember the liquid in the thermometer, the system should be the solution. Thermometer is only one of the surrounding only. Okay, just like the beaker. Okay, so the liquid in the thermometer as a surrounding, it gains energy because, okay, the reading goes up. That means the liquid inside it expands. Is that right? So why it expands? Because it gains energy, so therefore expand. So that means that, okay, the system itself, the reaction, the system is exothermic. It give out energy. It give out energy, and some of the energy, it will go into the liquid inside the thermometer. Okay, so this one is an exothermic reaction. So we find that in an exothermic reaction, if I have a thermometer, the temperature will go up. But on the other way round, okay, reading of the thermometer, if it goes down, that means the liquid inside it contract. Okay, it contract because the energy in the liquid is absorbed. Okay, so the energy from the thermometer, it got absorbed, okay, into the solution. Okay, so we say that this is endothermic, absorbing the energy. So normally endothermic reaction, the temperature will go down. Okay, so have a look of class practice 33.1. In experiments, hydrochloric acid was allowed to react with potassium hydroxide. So this one, HCl, react with KOH. Obviously, this is a neutralization reaction. So we will still remember, neutralization is an exothermic reaction. Okay, so the solution got warmer. Okay, that means you hold it, you feel warm. Okay, when you feel warm, okay, that means that energy is from the reaction mixture going to the surrounding. So in the above system, what substance constitute the system? The system, okay, that means the reactant. We are talking about the HCl, we are talking about the KOH, we are talking about the KCl, the salt formation, and also the water. But the water, okay, do remember we're talking about the water formed. Okay, because the reaction include KCl and also water. So these four things, that will be the system. Then what will be the surrounding then? Surrounding, okay, which include the water, which contain inside HCl. Because you know that this is HCl aqueous. That means you have HCl plus you've got some water. So this water, actually, we are strictly speaking, that will be the surrounding. But other than that, okay, because we put it in a conical flask, so conical flask, it will be the surrounding as well. And also around the conical flask, okay, you got air right there, right? So this one will also be the surrounding as well. Okay, and then state the direction of energy transfer during the system and the surrounding. Because the solution got warmer, the solution got warmer. That means when you hold it, you feel warmer. So therefore, the energy is going out. So this one is exothermic, and the direction of energy transfer should be from the system to the surrounding. Okay, from the system to the surrounding. So what was the change in form of energy? That means from what form to what form. So the reaction, okay, this is a chemical reaction. So it must be starting from chemical energy, go to heat energy. Okay, even physics tell you that, okay, there is no heat energy, but in chemistry we also state that as heat energy. Okay, so to summarize, first of all, we know that the study of energy change during chemical reaction or physical changes, okay, we call this kind of study energetics. Okay, this is the main theme of this 3 chapter. Energy transfer between the system and surrounding, okay, so it can go into the system or go out of the system. So the law of conservation of energy stated that energy can neither be created nor destroyed. That's why the total energy in this universe will remain constant. And if there is energy loss in the surrounding, it must be equal to the energy gained in the system. And it is true the other way round. Energy gained in the surrounding will equal to the energy lost in the surrounding. Okay, so if energy released from the system, it is an exothermic reaction. When you hold it, you find that the beaker feels warm. Okay, you feel warm. Okay, and the thermometer reading will also goes up. While the other side, okay, if you have all the energy absorbed by the system, okay, that one we'll call endothermic. You will feel cold because you are the surrounding, okay, the system absorbing your energy. And also thermometer as a source of energy, as a surrounding, it will also be absorbed. Its energy will also be absorbed. So the thermometer reading will also go down. Okay, so that's all for this video. Bye bye.